Let's take a brief look at the bioenergy potential and benefits and limitations. Afforestation, biochar, soil carbon enhancement can all be done for less than 100 ton of CO2 removed. So essentially this is what it comes down to. If you are doing, for example, direct air capture where the CO2 is such a trace gas, what is the scale of the plant you need to withdraw directly from the air, how much it would cost in terms of the energy to run it, and how much CO2 would it actually capture. So what would be the cost per ton? This is what it comes down to. I think currently those costs sometimes run several hundred dollars per ton, and there is some economic calculation about where it becomes economical. Okay, so 100 ton per CO2 removed. You have to have a sense of whether that's cheap or expensive, but it's cheaper than many others, and we'll see later on that these are considering the co-benefits and the CO2 removed, etc. There are already they are already net profit making, so they don't need additional incentives, for example. Okay, they have respectively maximum capacities of 4 billion, 2 billion and 5 billion tons per year worldwide. So afforestation, biochar and soil carbon have 4 billion, 2 billion and 5 billion tons per year just in terms of their CO2 drawdown capacity potential. But there are additional benefits for each of them, obviously. Biochar, we'll look at a little bit more. So afforestation, we already mentioned. Soil carbon and biochar are related in the sense biochar can also add soil carbon to add carbon to the soil. These are obviously capable of making a significant dent in the 20 billion ton that would be needed to be drawn down to stay on our below 2 degrees C target. I think this will not get us to 1.5, but anyway, it is a number that is bound to change as hopefully emissions decrease and not increase. Okay. So here is a summary map of biomass resources in 2040 projected in the United States, available at a cost less than $60 per ton of dry biomass. Map colors show the available tons of dry biomass. Dry ton DT is shown here per square mile of area. So these are the western drier states, especially into California, and yet some parts of California, not all of California is dry, but large parts which are dry in fact are being irrigated heavily and have become massive agricultural producers of various things like artichokes, fruits, dry nuts, etc. So there is impacts, negative impacts on soils as well because of excess irrigation approaches and so on. As you go to the Mississippi watershed going all the way from the Gulf of Mexico up to the Canadian border, you have the breadbasket of the US with large biomass available in various forms. So that is in the order of here, the highest color here is order 1,000 to 5,000 dry tonnage per square mile, and varies from 100 to 500 to 1,000 with upper limits of 5,000. Okay, and you get here seasonal agriculture, which winter times are basically not very productive, so the biomass drops as well. If you zoom out to the world and look at where bioenergy plants are already functioning for various purposes like electricity only, co-firing, combined heat and power, and also additional heat, under construction or conversion, and co-firing and so on. So these are the color scales or the color representations of these various things. And you can see that the European regions into Scandinavia all the way into Norway dominate the scene in various ways, and US and Canada obviously have lots of them, and also here down into South America, Brazil and Argentina, Chile, and some of the Caribbean islands as well. Fortunately, also a few in Africa. Surprisingly, nothing in India, and of course, Japan and Korea have a lot of them, with some in Australia. And there are pellet mills as well, which now India shows up on the map. Pellets are a better way of doing biomass burning, as we saw when we talked about cooking with biomass and biofuels. So that reduces emissions by a lot. So producing industrial and domestic wood pellets with an annual production of more than 50,000 million tons per year, active and planned. So US has a lot, Canada has, Europe again shows up. Now you also get some here in Asia, all the way into Russia, China, Korea, and so you can see the difference here. In bioenergy, they're not very active, but in terms of pellets, they are. So whatever helps us to reduce CO2 is always good news. This is another projection out to 2050, looking at the potential. I liked this one from this paper because you can look at these maximum harvestable net primary production, so agriculture and other forms of vegetation that are harvested for various reasons. And these are graded here as risk of tropical forest encroachment. We already saw forest perturbations and emissions from these regions. So they're all here highlighted as at being the risk of tropical forest encroachment. Risk of savanna degradation, a vegetation type. Vulnerable drylands, obviously over here in the deserts of the southern and northern hemispheres, and remote and unproductive regions. But this map here also shows risk of food versus fuel competition. Okay, and there are some numbers there. This is critical. Every time corn became a big additive as ethanol to fuels, especially during dry years when the production of corn went down, like around 2011, for example, I think, there was competition for grains for people versus grains for animals versus ethanol production. So bioenergy is always going to have this issue of food security for some people, whereas rich countries may prefer to use it for biofuel or other things. Okay, so risk of tropical forest encroachment, vulnerable drylands, remote and unproductive regions, and so on and so forth. So bioenergy is a good option for bending the curve, mitigating greenhouse gas emissions, and having co-benefits, but there are issues to be dealt with. Okay, so there is a link between afforestation, soil carbon, bioenergy, food security, water security, and so on and so forth that have to be considered in sort of life cycle analysis that we talked about, to make sure that they are actually net negative as well as not creating other problems, other unintended consequences.